So this one's about a particle. It gives us an acceleration formula. And it gives us initial conditions. That's what they're called. So it says the position at time 0 equals 3. That's going to be important. And velocity at time 0 equals 1. And we're going to figure out the position at time 8. So it looks like we're looking for S at 8. Okay, so this first requires us, we need a function for S. Okay, we could actually figure that out. So if you remember, S of t, so that's usually position with given time. Remember that the first derivative is going to be velocity. Okay. And so it looks like the second derivative is going to be the first derivative velocity, which is just going to be acceleration. Okay. So for given acceleration, we want to go back. So it looks like if we're undoing derivatives, that would be integrating. So that's what we can do. So this is an integration problem. So given a of t equals 36t plus 8, it looks like velocity at time t will be the integral of our function a of t. Okay, and so it looks like we're going to integrate that. So integrate 3t plus 8 dt. Looks like that's going to be 3t squared over 2 plus 8t. And then we got to add a constant. Okay, I'm going to call it C1 because we're going to have to do it again. So that means it's going to be a different constant. Okay. Well, something interesting, we're actually given velocity at time 0 equals 1. Okay. So this is saying that when we input 0 into this equation, we better get 1 on the output. So let me plug in 0. So negative 3 halves times 0 squared plus 0 times 8 times 0 plus C1. This better equal 1. Okay. Oh, look at that. That goes away because that's 0. That goes away at 0. C1's got to be 0. Okay, so it looks like we have 3 over 2. Oh, it looks like it's not even negative. Doesn't change a thing, though. So 3 halves t squared plus 8t plus 1. Okay. So now if we want to find the position, S of t, we got to integrate the velocity. So we're going to integrate 3 halves t squared plus 8t plus 1. Let's see what we get. So we got the 3 halves t cubed, and then we got to divide by 3. Oh, notice those 3's go away. Okay, I'll write that later though. Then we got 8t squared divided by 2. It's going to turn into a 4. And then plus integral of 1 is just t, 1t. And then we got another constant. Okay. So, oh, well, remember, let's do the similar thing. At position, at time 0, we get 3. So if we plug in a 0, we better get 3. So I'm going to simplify this to be 1/2. Okay. And t squared. So our t in our case was 0, cubed. Okay. Plus 4, because 8 divided by 2 is 4. And our t is 0. And then we got to add another 0. Then add C2. And that better be 3. So, that goes away, that goes away, that goes away. C2 equals 3. Okay. So it looks like we now have a function, S of t. S of t. Sorry, it's kind of hard to write with a mouse. So S of t looks like that's simplified down to 1/2 t cubed plus 4 t squared plus t plus 3. Okay. And okay. So now we can actually figure out what happens at time 8 with the position. So s at time 8, every time we see a cube, every time we put a t, put an 8. So 1/2 times 8 cubed plus 4 times 8 squared plus 8 plus 3. Okay. Whatever that's going to be. We're in calculus. We don't need to do all that. We can do that for a calculator. Okay. So I use photo math, and it simplifies to 523. Wow. So it looks like that's the answer, 523. Okay, and that's it.